All right, so we're back. So now we're going to go over lesson 3, which is mole to mass conversions. We are looking at, we've actually already kind of checked our table of contents here. We have already done the molar mass lesson. Make sure you do that first. Then we're going to talk about moles to mass conversions. Then I'm going to do a side video that's kind of extra, but will help some of you who are having some trouble. All right, so just to kind of give you an idea of where we're going, if we look at our problem, we always want to mark up our problem and figure out what exactly we want to know. So our knowns that they have given us are the number of moles of the substance. Okay, so they gave us that information. And then they want us to find grams. Ultimately, they want us to find grams. Let's have a red. I don't have a red handy, so we'll just use pink. I would prefer to use red here. Let's just use a different kind of pink. That way it doesn't look quite like the sticker that we're looking for there, okay? Now, again, whenever you get a test, you always want to mark up the question. That's what good test takers do. If this is your, like a question from a book or worksheet that you have to turn back in, you don't quite get that option, but I'll show you what you should do instead. So first thing you're going to do is you're going to look at your mole map and you're going to see where you're looking at. Your known value that you started with. Your known value that you started with was moles. So you're starting here with moles. And your unknown is going to be your grams, which is mass. So you know that you have to take this root A in order to get there, okay? It's important to have that conversation with yourself, especially if you're visual, kinesthetic, audio. No matter what type of learner you are, you need to have that conversation with yourself as to where you need to start and to where you need to finish, or you can actually wind up doing a whole lot of work over here and getting to the wrong place. Quick analogy, you're trying to meet your friends over in Tinleytown at, I don't know, that Guapo's over there, and you wind up going to Gallery Place. You wind up going to Target. Completely wrong direction. So you have to make sure that you are looking and following the right direction. You can also see that because you need root A, that at the bottom of your page, you're going to need this conversion factor that's there. We'll deal with that in just a second. All right, so let's set up our problem. So with any problem that we have, we always need to list our knowns and our unknowns, right? Every single time. And then after that, we are going to need to talk about what our conversion factor is. And some of you still have forgotten that conversion factor and CF are the exact same thing. And then we'll need to do our setup and dimensional analysis, and then give our final answer circled. So this problem is probably going to take almost the entire sheet of paper, just to kind of give you a lay of the land. Once you get good at it, it doesn't take that much space, but for now, it will. All right, so our known that we had was 6.32 moles of the lead carbonate. Be very careful not to confuse that for another C. That's a common misconception. And if you can't see see this very clearly, definitely expand your window so you can see the whole problem on the page. I would make it bigger, but then as we move forward, I can't talk about things that are at the top. And then our unknown is going to be the grams. And specifically, we are looking at grams of lead carbonate. Sounds silly to even say that, but later on, as we move into our journey of solving problems are going to get more and more complicated, and so it becomes important that we make sure that we're clear about what substance we're looking for. Just to make things a little bit clearer later on, I'm going to go ahead and put this little yellow thing right here, just to remind you that this is our known. And I'm also going to take that pen that I was using earlier to make sure that we are clear about our unknown. All right, so now we can do our conversion factor. We've taken care of the first two. After this problem, I'm no longer going to write out the whole word conversion factor. I'm just going to write CF. So if in your notes you would like to just write CF, that's fine, especially if you get that that's what this is. If you are someone who is new to this and you're still not really sure, definitely write out the whole thing. So we know that our conversion factor has to be blank grams of X is equal to 1 mole of X. Okay, and we would do the same process that we did before on the previous piece of paper, which is 1 lead times 207.2 grams is equal to 207.2. Then we also had 2 carbons times 12.01 grams, and that was 24.02 grams. And it looks like my number was wrong in the last problem, so I'll go back and fix that in just a second. And then we had a total of 6 oxygens, and that number was 16.0 grams, and that was 96.0, and then we add that all together and we got 327.2, and I believe it should have been 2, which is what I wrote down. Well, actually, now that I'm looking at it, my math was correct, 24.2 and 24.2. Okay, so now let's do our setup. Now, some of us really like to have straight edges. Oh, I'm sorry. We didn't finish our conversion factor. We need to go back and fix our conversion factor. We know that we need root A. And one of the things that I kind of like to do is to kind of like do a kind of a sketch. So I know that I'm going from mass. Well, I'm trying to get to mass, but I'm going from moles and I'm using root A. That's just kind of a thought process for me so that I know which conversion factor I'm using. And you guys know that when I put things in bubbles, it's not something that you have to write down. It's just very helpful. So our overall conversion factor is actually 327.22 grams of PB CO3, close parentheses 2, is equal to 1 mole of PB CO3 2. That's your conversion factor. Just to make sure that we know this is our conversion factor, I'm going to take the same green sticker that we used earlier on the mole map here, just to kind of make it clear, and it'll make sense why we're doing that in just a couple minutes. All right, so now let's do our setup. So for a setup, we need dimensional analysis, and dimensional analysis is a way that scientists use units to help us solve math problems. You can use any straight edge ruler, helps. I typically just keep a quick card, so I'm going to set up my conversion factor. You will probably want to use, especially if you're a big and bubbly handwriter like me, 2 blocks above your line, and then 2 blocks below your line. You know you're going to need 2 sections of your line. And your question is, well, how do I know that I'm going to need 2 sections of my line? Well, you only have one conversion factor. You have your moles, you're starting with your moles, and you're using your A to get to where you need to get to. That's your train, and then you're getting off at mass. So you're going to need your known, will go in this box here. Your conversion factor We'll go in the next section. And that, I don't like the way that looks. You guys know I have perfectionist tendencies, so we're just going to change that to A. And we're going to draw a line here to kind of create a fraction. I'm going to show you what this could also look like if you do not like these particular lines in just a minute. And then your equal sign. And your equal sign will give you your answer. So your known was this number here. You're going to write that in the box. 6.32 moles PbCO3 2. Warning, if you write some big like me, don't try to squeeze that in, which is why it's important to use pencil. So that if you need to make your line bigger, you can. The worst thing that you can do is have all the right ideas, but have your writing so sloppy that you can't read your own stuff and then you make little mistakes. So PB parentheses CO3 close parentheses 2. All right, now next section. Here's our conversion factor. One side of it has grams of PbCO3. The other side has moles of PbCO3. And I'm greatly saying that bad. It should be PbCO3 parentheses 2. Nonetheless, you always want the unit that is on the known to be at the bottom of the next step. So because moles is here, you're going to want moles at the bottom of the next step. If you follow this rule of always making sure that whatever is here, everything always works out. You'll be able to solve problems that no one ever even taught you how to solve just because you know how to cancel stuff out. That's how I made it through high school or college physics. So at the top, we're going to put in our 327.22 grams PB parentheses CO3 close parentheses 2. Now let's make a little bit more room there. And we're going to do the math. And from the way that this is set up, we can see we need to multiply by the things that are on the top, divide by the things on the bottom. So we'll have 6.32 times 327.22 moles, and PbCO3 will cancel. And we'll be left with 1. And then our units of grams of PbCO3 at the top. A question that often comes up with students is, how do I know when to multiply and when to divide? The answer is after all this time of doing chemistry, I don't. Without doing the dimensional analysis, I can never be sure. So don't try to remember it. Try to figure out how to get a consistent answer every time. 6.32 times 327.22. My calculator gives me this answer of 2068.0304 is the answer that the calculator gives. So we have now figured out our setup, and we now need to figure out our final answer. And our final answer, we need to put this in scientific notation. Scientific notation always has the decimal after the first digit. So that would be 2.06800304 times 10 to the, how many places did we move that? 1, 2, 3. We moved it 3 places, and the original number was bigger than 1, so we're going to leave that there. And then we don't want to forget our units, because without units, grams, where are units? Without units, our answer is not correct. Okay. Now, for now, if you would like to leave your answer here, I'm okay with that. You will not get the 4-point answer. We'll talk about sig figs soon. When we do, I'm going to ask you to go back and to fix your answer. But to make a very long story short, and you also can Google sig figs and sig digs, and I probably will put a lesson up pretty soon. We go back to our knowns. Our known had 3 digits, significant digits in it. And all of our other calculations had about 3 significant digits in it. So our final answer should have 3 significant digits in it. So our final answer, we want 3 digits, which means we need to look at this one to decide whether we need to round up or down. Looks like we need to round up, so we'll wind up with 2.07 times 10 to the 3rd grams of PB, parentheses, CO3, close parentheses, 2. The goal for the lesson today is to be able to get from here to here. Okay? If you can get from here to here, you're doing great. Don't worry about it. We'll figure out this sig fig thing once I come back. It won't take very long at all. All right. I'm going to now do lesson 3.5 for people who need it.